As promised, the last video of the review. So, family function name. There are many families. There's linear families, absolute value families, quadratic families, cubic families. The only way I know what kind of family this is either by the equation or by the graph. Because this looks like a V, that means this here is an absolute value function. Can't be anything else. Parent function, bare minimum. Well, I have to have absolute value bars. So what is this function dependent on? It's dependent on x. That's it. Bare minimum. Now I have to figure out what the graph of the equation is. So let's go over here. We've done this before. Y is equal to A, absolute value, x minus h plus k. So I have to find my h and my k, because that is right here. Those there give me the vertex. The vertex is right here. So the vertex is at -2 and 1, 2, 3, 4. Okay, it's at -2, 4. So that means I'm going to have y is equal to a absolute value of x minus, I'm going to put my h in there, and my h is -2, and then I have a plus 4. So this means y is equal to a absolute value of x minus gives you a plus 4. Okay, so I'm almost done. I have to figure out what my a is. And remember, my a is like slope. So I simply look for where it goes through the crosshair. It looks like it goes through right there. So how do I go from my vertex to the next point on my right? I go down 1. And I go right 1. So down 1 is -1, right 1 is +1. -1 divided by 1, so this means my a is -1. So the equation of the graph is y equals negative absolute value, you could write -1 if you want, x plus 2 plus 4. Now, domain. Domain is what values can I put in to draw this function. This is not the vertex. This is not the x-intercept. This is x input values. So when I'm looking at my x input values, I can look here at x, and I go up, and I see I have a point. Here I have a point. Here I have a point. Here I have a point. So you can see that if I were to hold my stick vertically, it's always touching the x-axis, and as I move it, it's not only just continuing to touch the x-axis, it's also touching the function. So this function is forever wide. It keeps getting wider and wider. That means I'm starting where x is -infinity, and I'm going to where x is infinity. So this means all real numbers. So forever wide. So that means I'm starting at -infinity, and I'm going to +infinity. This is always true with absolute value functions. This is always true for domain. What we have to pay attention to is the range. You have to pay attention to the range. Okay? So, the range. When we're thinking range, we're thinking all possible output values. So, how tall is the function? So you have to remember that this is going down forever. So where's the floor? If I were going to figure out where the floor was, it's way down here somewhere, and it keeps going. So my floor there is no floor, it keeps dropping. But then where's my ceiling? I go up, 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 and the highest point of my function is right here. And where is that? That's right here. That's where y is 4. So y is 4 at the top and negative infinity at the bottom. So basically y is everything less than 4. So this is where y is less than or equal to 4. I could write that as I'm starting at the floor at negative infinity and I'm going all the way to the ceiling. It includes the ceiling. So this is just an inequality. This here is interval notation. This is interval notation. This one means all numbers. I'm just going to put all numbers instead of all real numbers. It means the same thing as far as I'm concerned right now. X-intercept. You guys struggle with that. X-intercept. I have two. I have an x-intercept here, and I have an x-intercept here. Those are my x-intercepts. So my x-intercept is where I have some value of x and my y is 0. So my value of x right there is 1, 2, 3, 4, 5, 6, negative 6, y is 0. The other one I have is at 1, 2, y is 0. So notice x-intercepts is the same as the zeros of the function. Y is always 0. Now my y-intercept, I should only have one of those. So my y-intercept is right here. So my y-intercept is where I'm looking for y. Notice it tells me what I'm looking for. My x is 0. So what is my y? My y is 2. X is 0. Y is 2. That's my x-intercept. Increasing interval. Well, this is a positive slope. Where does it change direction? It changes direction at x is negative 2. So here I have an increase, and it's increasing from where x is negative infinity all the way to x is negative 2. So my interval of increase is from negative infinity all the way to negative 2. This part here, forever, notice I went beyond because it's going forever, is my decrease. Where does that start? Well, that starts at negative 2, and that goes forever to positive infinity. Remember, we're looking at x values. So this here, negative 2, all the way to positive infinity. So remember, this is what values of x change the y. Okay, so I'm looking for values of x. This here, my y is getting bigger. This here, my y is getting smaller. Continuous. Can I draw this function without ever having to lift my pen off the paper? The answer is yes, and good for you. We're done. We're not going to do end behavior.